All right, today we're going to talk about a problem that, let's be honest, haunts a lot of engineering teams. We're going to use a core architectural guideline from the folks at Wix to explore how they build systems that can actually scale and, not fall over.
So, let me ask you something. Have you ever worked on a system where you were just afraid to make a change? You know that feeling, where one tiny little tweak grinds development to a halt and you're worried it could bring the whole thing crashing down? If that sounds even a little bit familiar, you, my friend, might be dealing with what's called a big ball of mud. So, yeah, let's properly introduce the villain of our story today, the big ball of mud. It's a fantastic term for systems that have just become so tangled up, so interconnected, that they're practically impossible to understand, a nightmare to maintain, and forget about trying to evolve them. So, what's the real problem here? It all comes down to something called tight coupling. This is what happens when your services are so dependent on each other's private internal details, especially their databases, that they can't really operate on their own. You change one little thing in a service's database schema, and boom, you've unknowingly broken 5 other services that were secretly depending on it. But don't worry, there's a really elegant and powerful principle to fight back against this complexity. And it all boils down to creating some really clear boundaries with one simple rule. And here it is, the database per service pattern. The idea is actually super simple. You've got to treat a services database like it's its own private property. It's part of the internal machinery, and no other service gets to just trespass and query it directly, period. So, okay, if a service can't just barge in and grab data, how do they actually talk to each other? Well, if service A needs something from service B, it has to ask politely. It does this by calling a public, well-defined API, or by listening for a public event that service B sends out. This way, service B's database stays a complete black box, totally protected. Now, when you enforce this separation, something really cool happens. Each of your services gets, well, they get a set of incredible superpowers. And this isn't just about keeping things neat and tidy. This is about making your whole system stronger, faster, and way more flexible. And the benefits here, they're huge. You get encapsulation, where a service is the true owner and master of its own data. This naturally leads to independent evolution, so you can change a database without getting panicked phone calls. You get failure isolation, a big one we'll talk about in a sec, plus the freedom to optimize storage and scale each service exactly how it needs to be scaled. Okay, let's really zoom in on failure isolation, because honestly, this is a game changer. If one service's database gets into trouble, maybe it slows down, maybe it fails completely, the damage is contained. It's firewalled off. Since no other services are directly plugged into it, you avoid that catastrophic domino effect that takes down your entire platform. Nobody wants that. All right, enough with the theory. Let's make this real. Let's walk through a practical example so you can see how this all works in the wild. So, meet our 2 services. In one corner, we have a user service. It's the single source of truth for every piece of user data. And in the other corner, we have an analytics service. Its job is to generate reports, and to do that, it needs some of that user data. The stage is set for a classic architectural showdown. So here's the million-dollar question. How does that analytics service get the data it needs without, breaking our big rule? And here's the breakdown. The wrong way, and I mean the really, really wrong way, is to let the analytics service just reach in and query the user service's database directly. That creates that exact tight coupling we're trying to escape. The right ways are to either call the user service's public API to request the data, or to listen for events like a user-created event that the user service publishes to something like Kafka. Okay, but what if calling an API for every single report is just too slow? I mean, that's a valid concern, right? This is where a really useful pattern called a materialized view comes into play. The analytics service basically keeps its own local, optimized copy of just the user data it needs. And this is the key detail. You only copy the absolute minimal subset of fields required, maybe just the user's ID and sign-up date, not their entire life story. Now look, adopting this pattern, it isn't a free lunch. It's not magic. It actually requires a pretty big shift in how you think, and it forces you to solve problems in totally new ways. So let's be real and talk about the trade-offs you have to make. So yeah, you lose the ability to do those simple, comfy SQL joins across services. The solution? You use materialization instead. You can't rely on those old school distributed transactions anymore. You have to move to asynchronous flows and build what are called healing processes to fix data discrepancies later. And this means you have to get comfortable with the idea that your data will become consistent eventually. These are huge shifts for sure, but there are established, well-known patterns for all of these challenges. So as we start to wrap this up, it is so important to frame this powerful idea in the right way. It's not some dogmatic law you have to follow blindly. Think of it more like hard-won wisdom from people who fought these battles before.
This quote from the Wix guideline really says it all. This is a guideline, not a rigid rule. You should use your engineering judgment. At the end of the day, architecture is all about making smart trade-offs for your specific situation. You're paid to use your brain, not just to follow a checklist.
I mean, look, for a tiny project or maybe a quick prototype, a shared database might be totally fine for a little while. But the second that system starts to get real use, the moment it needs to scale, you'd better have a plan in place to migrate towards this more resilient, separated pattern. So the next time you're designing a new feature or spinning up a new microservice, I want you to ask yourself this question. Is it ready for its own database? Because by giving it one, you might just be saving your future self and your entire team from that dreaded big ball of mud.